Hello, and today we will be covering how to take the derivative the limit way, as well as understanding what that is. This can be helpful if you have never taken the derivative before, or you want to relearn how to do it the limit way, or you get caught up and confused on how to set it up. This is the same question if you are asked to prove the derivative. So, let's get started on what it is. If you want to skip ahead and see how it's done, just go ahead. First, I'm going to show you what type of derivative I'm talking about. Let's say you're given limit, oh, that's kind of big, my bad. Clear that. 1 second. Limit of h going to 0, sorry, I'm not the best at it, of x plus h f of x minus f of x all over h. Okay, I'm talking about these kind of problems. And then they'll give you a function like, I don't know, x squared plus 5. Okay, so how do we take that? How do we pop that in there? And what is that? This is all what we're going to be covering. Okay, so let's start out with what it is. Okay, let's say you have your x and y axis. Now, let's say they give you the function, let's start simple with y equal to x. Now, what is the derivative? The derivative is actually the slope. So, what is the slope equal to? M is equal to delta y over delta x, which is just y2 minus y1 all over x2 minus x1. Okay, so it would just be as simple as you take 2 points, so let's make this our x1, and then that's our x2, and then that would just be our y1, and that would be our y2. And you know how to just plug those 2 points in, and then you'd subtract them, and then divide them, and then that's how you get your slope. But that is also what the derivative is. Only the derivative is the slope over a very small point, or over a very small distance, my bad. So let's say you have another x and y, and let's say you want to take the slope when it's at right here and right here. Or let's say you want it to be infinitesimally small. So that distance from there to there will be from x to that distance right here. It's a very small distance. But what will we describe that distance as? It will be the distance from x to x plus h. And as you can see, then that y value would just be y, or f of x, y is equal to f of x, and it'd be y, or f of x, and that would just be f of x plus h, because that is how much the x values are offset. So that'd be f of x plus h. So then when you're taking the derivative, it'd just be f of x, it'd be f of x plus h minus f of x all over delta x, or it'd be h in this instance. So, let's say we want that distance to get very, very, very small. The distance, how small we want it to be, would be the limit going towards 0. Because if h gets progressively smaller, like as small as possible, then there's really no distance between x and h, so therefore it would just be h heading towards 0. I don't know if you've taken limits before, I assume you have, but it's just where the point is heading towards. And let's say h is heading towards 0. So that means the distance is very infinitesimally small. So now you're left with the limit of f of x plus h minus f of x all over h, or you might see as delta h, either or. So that is how we get this formula. Now, let's clear this. So how do we actually do this? Right, so let's start out with writing out limit h going to 0. Sorry, I'm getting the hang of this whole mouse thing. F of x plus h minus f of x over h. Now, in short, all you have to do is plug in x plus h where you see all your x values, similar to how you write your f of x. And you just write x for all your spots. So let's say we'll take the function x squared plus 5, and that is our f of x, equal to f of x. Sorry I'm writing on that side, but there's no room. Doesn't technically make a difference, but still. Okay, so now let's start out putting in this formula. Let's write out our f of x first. So f of x is equal to x squared plus 5. Now mind you, since there's a subtract sign, we put that in parentheses with the minus symbol. Now how do we do x plus h? Well, it's simple. First let's write out the whole function, but only I'm going to put parentheses where the x is. So squared plus 5. Only instead of putting x there, we're going to put x plus h. See? And that's all there is to it. And then it's all over h. And then don't forget your limit, because some math teachers will not like that. And it makes sense. You don't want to forget it. Okay, now we have h going to 0. Now that's how you set it up. I'm going to do a few more examples of how to set it up, because it can trip people up, and that's part of what we're covering for. So let's say we have x 2x squared plus 5x minus 3. How do we set this up? Oh, and that's our f of x. Formerly known as y. Same thing, but, you know, it's better to say that it's dependent on x. Okay, now we have our limit. H going to 0. Now this is just showing you how to set it up before we actually tackle some problems. F of x plus h minus f of x all over h. I'm going to get a better mouse, so in future videos it'll be a little less sloppy. So let's start out by writing our f of x. Our f of x will be 2x squared plus 5x minus 3. Now I'm going to do the same thing. Don't forget the minus part because of up in the top function, or this right here. Now let's write the f of x plus h. So write your f of x and put parentheses where all the x's are. So 2 squared